So for problem number 1, we are asked that x, y are independent, and we have fx and fy, and we have the relationship of z and x and y, and we need to find z using two methods. Okay, so for the first convolution method, actually we can first draw the original fx, which is from 0 to 1 is 1, and otherwise is 0. And for fy, it's the same as the fx, and then we use the convolution method here. And so we take fx and fy into the integral, and then we can do the calculus, and we get the result of z minus z minus 1 times u of z minus 1, and minus this part is the same, and plus z minus 2 times u of z minus 2. So for this line, we can draw the fz graph, which is like a triangle. And the question gives us another form of fy and fx, and so we take these two into the formula, and we can easily get the final result of fz, and we can see that it's actually moved, shifted right 1 unit compared to this original fz. That is the convolution method. So for the geometric method, actually we need to think 3 conditions. The first case is that if z is smaller than 1, we need to draw the graph of x and y, and we cut the line here, which is the z is smaller than 1, and we can calculate the square, the shadow square, which is z square over 2, and we take the derivative of it. We get the result that the density is z, and if z is greater than 1 and smaller than 2, we can see the graph here. And for this case, we can also calculate the shadow area here, which is minus z square over 2 plus 2z minus 1, and we take the derivative of this, and we can get the density function of z, which is minus z plus 2. And for the third case, if z is greater than 1, we can imagine the graph easily that all the square area will be shadowed, so the fz will be 1 and the density function will be 0. So to sum up, the final result of these 3 cases above will be this one, which is the same as the convolution method.